Good morning, everybody, and welcome to the webinars. Bring your AI applications to the new heights. Okay, so we are all together during 1 hour and 15 minutes almost. All the audience are in a listen mode. You are automatically muted. You can ask any questions at any time by using the question box. We will answer you in live or later on. The seminar is recorded. You will receive later on an emails that will invite you to download the videos, and you can keep the videos for you. All the participants will get access to a promotion kit. This is i.MX i-Wave single board computing that is based on the i.MX 93s, and there is inside an OSM mounted. Okay. So many thanks for all the parts. Let's say all the peoples. So NXP is introducing a new processors, which is a dual Cortex A55 that gives you a good compromise in terms of performances, power consumptions, integrations, solution also that offer the capability to have intelligent artificial technology, implement this kind of technology, and also security functions. So we invited Shri Khan from NXP, which is a product marketing manager of i.MX 93s. He will present you the processors. Following to that sections, we will leave the voice to Tofi. Tofi from i.Wave is a product marketing manager. Tofi will present us the OSM, the new OSM standard. That's quite an interesting solutions to offer you the scalability, the modularity of the solutions. We will also see the full ecosystem around OSM that i.Wave is providing with the single board computing and the BSP. Then to offer you the capability to implement intelligent artificial, we invited from Ozone Sébastien Taylor, the Vice President of Research and Development. Ozone will show the full ecosystem of PC softwares that helping the people to customize and give the best-in-class models that could be uploaded into the processors and i.Wave platform. At the end, we will show you a small and fast videos with a demo of the i.MX 93s, and we will hand it by the questions we can have during the sessions. So many thanks for all, and I wish you to have a good time. I will leave now the voice to Shri Khan. Shri.
Thank you. Let me share my screen. Okay. Hopefully, I've got the correct screen. Can you hear me?
Yeah, it's okay.
It's okay. Yeah. Okay. Cool. Let me start. I'd like to first start by thanking Future and i.Wave. Future for organizing this and facilitating our interactions with i.Wave, and i.Wave for being part of our early access partner program for i.MX 93. So as mentioned, my name is Srikanth Jagannathan. I go by, you can call me Sri if it's easier, but I'm the product manager of i.MX 93. I'm from NXP based in Austin. So as we can see, the number of edge devices have been constantly increasing over the years, and it's continuously going to keep increasing. Like we see a lot of applications today are moving towards edge computation rather than a server or a cloud. So as the number of edge devices increases, what are the key features that the edge devices need to have? Is something that's of a big, as a product manager, That's one of the biggest problem statement you want to answer. Like, what do you want to put on the chip? So one of the key features, apart from the performance, right, which is kind of known, we need performance. But apart from that, what are the other key features? The first one that comes is the power. So as you keep increasing performance, intuitively the power is going to increase, but then you want to have lower power as possible. So we need to do everything possible from architecture, from design, from technology point of view to reduce power. The next big thing is the security. Because you do all these computations at the edge, you want to keep your edge device as secure as possible against any hacking or any untoward attacks on the chip. And then the third thing is the smartness. The smartness here refers to ability to run machine learning models, ability to make decisions based on machine learning. So having a dedicated neural processing unit that can efficiently run these machine learning models is something that we have seen showing great results from our last product, which was the i.MX 8M Plus. So we think and we see a lot of customers looking for these solutions with running machine learning models. So that's where the i.MX 93 is going to fit in. So just to show the different product families from i.MX. So you know i.MX is a big brand in the market, application processor side. This slide just shows like from our i.MX 6 series, and we go far beyond that, obviously. But just to give a perspective, as you can see, the 6 series filled with different product families positioned for different applications, starting from the Quad Plus all the way to a 6ULL, 6ULZ. The next generation was i.MX 7, i.MX 8. The latest one was i.MX 8M, of which the 8M Plus was the last launched product from NXP. The next generation is the i.MX 9, and that's where all the excitement is going to come in. The first product in the 9 series is this product, i.MX 93, which is what this presentation or the webinar is going to be about. And then just to give a quick heads up, we have already announced i.MX 95, which is our follow-on product in this 9 series. And then we do have other 9 families in the works. So quickly diving into i.MX 93, what are the key features and differentiated features on this product? So starting from the top left, security, as I mentioned, is one of the key features that needs to be on the chip. And we are using an edge-lock secure enclave. If you're familiar with our edge-lock series from NXP, you're going to see all the good features, best features from the edge-lock we are directly integrating into the chip. So it provides every security functions that are needed for the chip, such as secure boot, secure debug, key provisioning, and also trust provisioning. So the next thing is the power. As I mentioned, the other key feature parameter that we need on these edge devices is the ability to control power. So using an edged energy flex architecture, we are able to provide flexibility for customers to tune the different parts of the chip. When I say tune, what I mean is ability to control the frequency of clocks as well as the supply voltage level. So the way we are doing this on i.MX 93 and also the future products in the 9 series is we are dividing the SoC, the chip, into multiple domains. Each domain is separated out for its functionality. So for example, the A55, which is the application code that is going to be used in this family, is part of the application domain. And the M33, which is the MCU that is also part of the chip, will be part of the real-time domain. And then any other processing unit or any other subsystem that performs specific functionality, such as, say, for example, we have the on-chip neural processing unit for this chip that will be part of a flex domain. So once we divide these into multiple domains, we control. We have these domains separated out in terms of clock and supply voltage. So each have its own independent clocks and supply. Thereby, customers can go and basically turn on and off domains that are not needed, as well as they can even run at lower frequencies if the performance is not critical. So that way, it gives the customers an opportunity to basically tune the power to their budget. Then the third thing is the scalability from compute. On this chip, we have a single and a dual core A55 option. So you can basically move from one part number to another part number within the package, since it's pin-to-pin compatible. And then, as I already mentioned, apart from the A55s, we do have the M33 core to perform real-time application, which is critical for industrial or say even an automotive application. And also, not only that, right? Even without real-time application, even if you want a chip to be operating at a low power state or low power mode, when the performance is not too critical, you can turn off the A55 and keep the chip operating and controlled by the M33. So thereby, we're able to save a lot of power by just going from one mode of operation to the other mode. So, and then the other key feature is the smartness that I had already talked about in the previous slide. The smartness comes in the form of having a dedicated neural processing unit. We are using an ARM Ethos U65 neural processing unit, which is highly efficient in terms of performance, in terms of power, and also in terms of the area that it consumes. We have seen great results on comparing running these different machine learning models on this NPU compared to running it on a A55. So it shows the importance of having a dedicated NPU for applications that need machine learning computations. And then apart from all this, we have a very, very rich set of interfaces capable of going towards different applications in the different segments. So I do have a separate slide on target market, but then the key thing is to keep in mind the interfaces are critical if we are going after target markets, and we have packed in a lot of good interfaces on this chip. So the next slide, I'm showing the different packages and the different configurations and the features on the chip. So the way this is divided is we have three package options on this part. So we have a 11 by 11.5 millimeter pitch and a 14 by 14 millimeter 0.65 millimeter pitch. Both these packages are exactly the same, no differences in terms of feature sets or the pins. The main difference here is the pitch size. And we are positioning the 14 by 14.65 millimeter pitch for the automotive segment, because typically automotive segment needs bigger pitch size to adhere to some of these automotive board layout rules. The third package that we have is a 9 by 9 0.5 millimeter pitch package. So since it's a smaller package compared to 11 by 11 with the same pitch size, it obviously has less pinouts, and hence you see some of these features or interfaces not part of the 9 by 9. So the interfaces that are part of the bigger packages are that are not on the 9 by 9 is highlighted in the blue color. So going from top row, as I mentioned, the A55 is the application core. So we have an ability to choose between one or two cores on this product. The M33 is the MCU that we've selected. So again, for low power applications or for running real-time applications, this is critical. So the frequency of operation for the A55 is up to 1.7, and we've found from the samples that we've tested that we are able to hit this top frequency across different qualification levels that we provide. So from the DDR perspective, the i.MX 93 will support LPDDR4 and LPDDR4X versions. Max speed of 3.7 gigatransfer per second, and it's a PI 16 on the bigger package. On the smaller package, the max speed is reduced to a 3.2 gigatransfer per second. So the way we position the i.MX 93 is it's towards a lower end graphical display kind of segments that doesn't need a lot of graphical processing. So we don't have a 3D GPU on board, but we do have something called a pixel processing engine in the hardware that can provide some basic 2D functionalities. So from other interfaces point of view, for example, the cameras, we support the BPCSI. On the display, we support MIPI DSI. We also have a LVDS display, which is kind of critical for industrial use cases. And for both camera and display, we support parallel interfaces. So from connectivity point of view, Wi-Fi connectivity, we have 3 instances of SD interface. Can be used for Wi-Fi, can be used for eMMC. We have 2 instances of USB 2.0. We have 2 instances of gigabit Ethernet, one with TSN. This is kind of critical for industrial applications. Typically, they need at least 2 Ethernet interfaces. So at least the 11 by 11 would be able to satisfy. On the 9 by 9, the Ethernet and the USB is reduced to 1 because of lack of pins, as well as we wouldn't have the MIPI CSI or MIPI DSI and LVDS. So the key target market, right? So everything fits together, like the features that we have on the chip with the interfaces, it fits into what target market we can go after. So for example, the MIPI CSI along with the A55 and the NPU, the Ethos U65 NPU, all of them makes the i.MX 93 very ideal for using for low-end vision applications. And this vision could be across multiple segments, like starting from industrial to consumer IoT, say smart home, all the way to even automotive, where driver monitoring system can be one such ideal use case that can be solved with the i.MX 93. And apart from vision, with all the interfaces that we have, with all the capabilities, i.MX 93 can be ideally used as a industrial gateway, can be used as IO controller, and also it can be combined with the NXP i.MX RT series, and both of them together can be used in industrial automation application. On the consumer IoT part, apart from the vision, we do have like 7 channels of audio along with the mic interface. So could be a very good solution for low-end audio soundbar. And then from the building control energy, one of the key use cases or applications that we see the customers are really excited on is the EV charging. So we already have customers looking and evaluating i.MX 93 for EV charging solutions. And apart from that, could be used as access control and also energy meter. And one thing is like, this is not by any means a comprehensive list. This is just a starting point. There are many more use cases and applications that can that i.MX 93 can be used on. So just quickly going through the part number list. As I mentioned, we have 3 packages. So the 14 by 14 and the 11 by 11 being it full featured will be part of a 935, 933, i.MX 935 and 933. And then the 9 by 9 will be part of i.MX 932, 931. And then we do have a i.MX 930, which is a lower speed version. We call it a value part. It's a lower performance version operating at lower supply voltages. And that is at this point, it's basically on the 11 by 11 package. So the different qualification levels that we support on this product are the consumer, which goes from 0 to 95 degrees Celsius. The standard industrial that goes from -40 to 105. The extended industrial that goes from -40 to 125, and the automotive, which is -40 to 125. The main difference between extended and industrial and automotive is the time on. The T on, which represents the amount of time the product is on, is 100%. So basically, when you do the qualification, we consider for an industrial use case, the product is always on 100% of the time, while for automotive, it's 10% on. So quickly going through the schedule, today we are close to the embedded world, where we're going to see a lot of these demos. iWave is going to show their own demo based on their SOM board using the i.MX 93. So from NXP, we are launching the 11 by 11 package pre-production. So just to clarify, it's not going to be production qualified because we have another version of silicon coming in. So this A0 version of silicon is going to be pre-production, and we're going to launch the EV case and samples in April, and then by October timeframe we should have the new version of silicon that would be production qualified, and the customers would have to shift from A0 to A1. It would be seamless because it's pin-to-pin compatible, no changes there. And then the 9x9 is going to follow the 11x11 within 2 or 3 months, and then finally the 14x14. And that's my end of my slide. And I'd like to thank i.MX again for being a partner with us, and also Future for facilitating. Thank you.
So thank you very much. I will leave the voice to Tafi. You're on mute, Tafi.
Yeah, thank you, Shri. Eve, can you just confirm if you're able to see my screen?
Yes, it's okay.
Okay. Yeah, so hello everyone. Thanks for joining in from across the world, and thanks Shri for giving a good overview of the i.MX 93. And we are equally excited as well, primarily from the covering the AI ML applications, and i.MX 93 as the right fit for those applications. So just to give you a quick background of what I'm going to cover in the next 20 minutes, is a quick introduction of i.MX, next covering on why system on modules, and giving a brief overview of the OSM standard, which is the new standard for solderable system on modules, and then throwing light on the i.MX 93 system on module developed by i.MX, which goes by the name as Rainbow G50M. And post that, I'll cover a few tips and tricks with regard to product design with the solderable system on module. And last, I'll show you the accessories available with the solderable system on module. So give me a quick background of who i.MX is. So i.MX, basically we started in the year 1999, and over the years have built a core competitive advantage in the field of embedded design. So embedded software, embedded hardware, FPGA, and I've built on these core competencies in terms of a design and manufacturing ecosystem, key partnership with silicon vendors, and NXP being one of our first partner since the year 2000. So we have been 23 years working with NXP, and we are proud to continue on that partnership. And as a product portfolio, we have been building on our system on modules portfolio and complementing it with some ODM solutions and design services. And as a company, we are focusing on 4 key verticals: industrial, medical, automotive, and avionics. And with AI being a driver in all these 4 verticals, we see a big push on embedded computing devices in the AI space in these 4 verticals. So looking at our partnership with NXP and the expertise we have built over the years. So we started with as an NXP partner since 2000, and in the year 2007 we introduced i.MX 27 single board computer. And as a company, we started building system on modules since 2009, and saw that it's going to be a big enabler for product development companies. And since that day, we have built a very strong portfolio of system on module, starting from i.MX 51, and today we stand at i.MX 93. So we have built a strong, extensive portfolio of system on modules, and continue to build a partnership with NXP, and starting from i.MX 6, i.MX 8, i.MX 93, and give joint solutions to customers. And working along with Future over the last 7 years, we built on a global sales agreement, and have been enabling customers globally with i.MX providing the complete embedded solutions, and Future enabling us from a sales perspective, where we go together in terms of joint customer outreach campaigns such as this webinar. So a very strong engagement between i.MX and Future, and also collaborating on product development and go-to-market strategies on specific opportunities, and i.MX 93 being one such product. So why system on modules? So i.MX did get into the system on modules journey quite early, and I've been continuing to focus on it as a core business unit. So the first reason being is it provides a lot of design flexibility and scalability. So you have a carrier board where you plug into a system on module, and you have multiple options of plugging in different types of system on modules, different depending on processor requirements, market requirements, instead of a chip down design where you're tied onto a single processor. And the second reason being the product development cost and risk. So with companies like iWave taking responsibility of the system on module development and manufacturing, companies can leverage our expertise and we help them build a career card so they're able to go to market faster with reduced risk. And it also enables a shorter time to market. Since they only have to develop a career card and the solution around rather than focusing on the intricacies of the system on modules such as the memory or the high-speed designs, companies are able to go forward faster. And the fourth reason being in terms of product longevity. So iWave enables customers, takes care of the complete PSP, the maintenance, the end of life. So companies don't have to worry about the hundreds of components on these system on modules and the boards. So iWave ensures that a software PSP cycle is supported for a period of 10 to 15 years as well as end of life maintenance. And last but not the least is in terms of supply chain complexity, which I'm sure every product company has faced on in the last 2 to 3 years, is companies struggling for components, paying tremendous prices. So with this system or module based approach, iWave takes the responsibility of maintaining and producing system on modules, where we take the responsibility of supply chain management, inventory control, sourcing, and stocking it for a period of 52 weeks. So which is where we are able to provide customers with shorter lead times as well as help companies reduce their risk and pressure on their supply chain teams. So why standardization? So we have seen standards such as Q7, SMARC, and recently the OSM standard. So that primarily comes from being able to build on the different capabilities of different vendors, reducing risk. So as the old saying goes, 1 + 1 greater than 2. So how do we build on the advantages and keep the modularity between different suppliers? So the first advantage being the standardized form factor instead of a proprietary form factor gives you access to multiple different technologies and you're able to easily upgrade since they're all plug and play scalable. And the second one being you have the reduced risk since you have interoperability between multiple suppliers. So you're able to reduce risk and you're able to play along with this complete in terms of supply chain uncertainty. And starting from SMARC and Q7, recently the OSM standard was announced. So why the OSM? So the first reason being in terms of ruggedness. So the different, the previous standards, which are all the connector based, such as the SMARC and Q7, the OSM standard is more a solderable form factor. So the ruggedness, shock, and vibration aspects are taken care of in this form factor standard, as well as it offers a reduced height. So products with height constraints, such as drones or tablets, this OSM standard is much better suited. And like in terms of height, you're also able to build much more compact designs, and you have the complete technology scalability offering much better aspects. And definitely you have the last point in terms of the complete the scalability and the modularity between the complete designs. So looking at how the OSM form factor is built in, is basically 4 sizes that are building upon each other. So here you have the size 0, which is a 15 mm by 30 mm. Here you have a size S, which is a 15 mm by a 45 mm. And here you have the size medium, which is a 30 mm by 45 mm. And then you have the size large, which is a 45 mm by 45 mm. And this is the behind where you have the complete LGA package. So you have these 4 standards that can build upon each other, and it's left to OSM manufacturers and customers to decide on what type of form factor they want to go forward, and depending on their product requirements and the product specification. And if I look at as a comparison of the pin to area ratio between the previous standards and OSM, this offers significant advantage. For example, in a 45 mm by 45 mm form factor, you are having access to 662 pins, which provides an area to pin ratio of 3.06, while compared to in a SMARC 20.89, a Q7 21, and a SODIM 8.78. So you're able to have significant pin to area ratio advantage from an area to pin ratio and significant advantages from a compact product design perspective. And now we are excited to launch the i.MX 93 system on module together with NXP. So it was we were one of the early access partners, and thanks NXP for that opportunity. And we have the samples readily available in Q1 2023. And as Sri mentioned, we will be there at Embedded World, and we'll be excited to show some live demos showcasing the AI/ML capabilities of the i.MX 93. So the i.MX 93 SoM from iWave is built on the OSM size L standard. So it's like LGA package in the 45mm by 45mm form factor with 62 contacts. And so we have complemented the i.MX 9352. So just giving an idea, we have integrated the 11 by 11 package. So you have the i.MX 9352 SoC integrated on this chip, on this SoM. And this is complemented with a 2 GB LPDDR4 and a 16 gig eMMC. And this can go all the way to 256 GB eMMC, can be expanded to that. And on the SoM, we have the Wi-Fi 6 and the Bluetooth wireless connectivity option. So you're able to easily leverage the wireless connectivity option to build products for such smart city and IoT applications. And complementing the hardware, we have the Linux operating system ready as of today. We'll have the FreeRTOS, and as and when a few the OS are available from NXP, we will be complementing those and supporting customers with such BSP. And we have the interfaces, like Ashley mentioned, the CAN-FD, the CSI, VPCSI, VPDSI, and the LPDS. So all interfaces brought out by the i.MX 93, we bring out in the balls of the solderable system on module. So starting as of today, most of your AI applications require like a driver monitoring system or a speech recognition or smart city, primarily require an image sensor. So which is where we go with the MIPI CSI interface, where we are able to connect some different types of cameras, image sensors, and leverage the integrated NPU to support such kind of AI ML applications. And the second one is in terms of the MIPI DSI and LBDS display options. So the MIPI DSI, you have the 1080p at 60 frames, where you're able to leverage the pixel, the parallel pixel engine. In spite of not having a GPU, you can 3D GPU, you can still have powerful display options on the i.MX 93. And the last is using the M33 core, you're able to provide for some real-time control applications, such as you're using the CAN-FD or the gigabit Ethernet, more from industrial and automotive applications, where you leverage this real-time operating system and the control features. And the last feature being the edge-lock secure enclave. So you have a lot of security features built in, the cryptographic algorithms, the secure boot, the key fuse storage, random number generator. So you have multiple options on this edge-lock secure enclave, and you're able to build on those security features. So now coming to the second section in terms of product design, how do you build a product with the OSM? So the first factor being, you need to decide on which form factor to choose. As I showed you, there are 4 form factors that build upon each other. So for example, it depends on what form features you want. For example, you require an LVDS, you have to go with a size L based OSM. Or if you require in terms of GPIOs or Ethernet. So it depends. It becomes like a conscious decision that you will have to take dependent on the features you require. So that is from one perspective. The second angle would be in terms of what kinds of wireless connectivity you want, to Wi-Fi 6 and Bluetooth or GNSS on the SoM. So accordingly, the real estate varies, which invariably you'll have to go for the bigger form factors such as size L. And the last one being in terms of the MCU versus the MPU, like what type of memory, what type of processor you want to go. So these are the factors that you will have to choose when going for what type, form factor you need to go for. But as a SoM vendor, what we recommend you is to go for a size L based product design, where you are able to then backtrack to the size M and the size S and size 0, since they are all form factors that can easily build upon each other. And then giving an idea of what contact technologies we need to use. So primarily there are 3 technologies defined by the standard. So a fused 10 grid array, the INIC LGA package, and the BGA package. So at i.MX, we have standardized on the INIC LGA package, and this is a sort of the soldering balls that we provide on the system or module to plug onto your carrier board PCBs. Now coming to a module height specification. So you basically have two types. One is the standard height and one is the extended height. So in the standard height, you do not have components on the bottom of the system on module. So you're able to easily solder it onto the carrier board. So where this is the system on module and this is your carrier board, and it is completely soldered. So there are no components on the PCB. On the extended height is where you have components on the bottom side. So you're able to easily place a spacer PCB or such as this, which then provides you the provision to integrate the bottom side component based system on module on top of the spacer PCB. So that is an option. Or the second option is to place a cutout on the carrier card, where you are then able to plug in the system on module directly onto the carrier card. So these are 2 options you will have to take depending on your carrier card design and what is the complexity on the carrier card. So when looking at product design with the system on module, these are mainly based on our expertise. These are the 5 main questions that you'll have to ask for. So one is the first question, as I answered previously, is whether you go for a spacer PCB or you go for a carrier cutout, which primarily depends on your complexity on the carrier card and the real estate available. And the second one is in terms of what OSM form factor you provision for in the carrier card. So as a SOM company and as our design guidance, we usually recommend companies to go for the OSM size L, so that can backtrack and take care of the other designs. And the third is in terms of the RF antenna location. So as you see here, the small rectangle, the 15 mm by 15 mm. So that is where the RF antenna location and breakout area is provided. So those have to be taken care of in your carrier board design as well. And the last one being in terms of the thermal consideration. So the OSM does not provide for the thermal heat sinks, the mounting option for the thermal heat sinks. So you have to take care of the mounting options, the screws on your carrier board. And that is what I'll also be addressing in the next slide. So here you don't have the small form factor. The OSM does not provide for a lot of space for thermal consideration, and there is no space for a screw. So you'll have to plug in a screw and spring-based heat sink through mounting holes on the carrier card, and definitely not go for an adhesive type, but rather go for a screw and spring strap, because you have multiple components of different heights on the system or module. And compared to the other standards such as MARC and Q7, OSMs are slightly better suited for thermal consideration, since you're able to, since it is soldered directly, so it provides a much more thermally conducive part for the complete product design. And not all is good with the system or module. You do have some challenges, right? So the first one is in terms of RMA and field replacements. So previously with the SMARC and Q7, you were able to just plug out the SMARC and Q7 and just plug in a new module. So RMA and field replacements are definitely a challenge. And then the second one is in terms of the programming and debugging at the time of production. Since it's not able to easily plug onto a carrier board, there is a lot of complexity with regard to programming. And the last one is definitely in terms of production testing. So point 2 and point 3 are definitely in line with each other, where there are some challenges, but we all are working towards the standards and companies together to come to some solution. So this is the first answer in terms of how we work towards the challenge of programming and testing the OSM through socket. So what you see on the right is the OSM socket board, where you're able to easily plug into OSM on this pogo pin based socket, and you're able to easily program and test. So such socket boards are also being developed by companies such as i.MX and other manufacturers, so they get rid of the programming and testing challenge. And what you see on the left is a JTAG, which JTAG and the debug and program connector, which can be used to debug as well as program the header. So such kind of accessories are being built by i.MX to enable and reduce the number of challenges that customers are facing on the field. And definitely there are companies who want a ready solution and do not want a complete to go through the carrier board design and the whole timeline of the carrier board and product design. So i.MX also enables customers with a production ready single board computer, and also as an evaluation kit, which E will touch upon in the next few towards the later part of this webinar. So here we have all the interfaces brought out, so the gigabit Ethernet, CAN FD, MIPI CSI, DSI, audio jack, as well as an expansion connector. So this is where here we have brought out all the interfaces so that companies can then easily go to market with their software capabilities and build on as a complete solution. And just coming across towards the end, so this is the OSM portfolio at i.MX. So i.MX has bet big on the OSM standard for the last year and a half, and building the complete portfolio, building on the OSM standard, the i.MX 8M Plus, the 8X Lite, and as of today, the i.MX 93. So in line with NXP's roadmap, we have samples available towards later part of Q1 and production plan towards Q4 2023 for the i.MX 93. And this is some standard which we are looking at, and good traction in the market for different kinds of applications. And look at the accessories together with the OSM. How do we enable customers? So as I mentioned, we have the single board computer where we have the interfaces available. We have also built across a generic OSM based board. So this is the same form factor as your Raspberry Pi. So you have the different types of interfaces, and you have more flexibility because we have brought out more IOs on this expansion connector, as well as you have additional features such as RGB display. And then we also enable the OSM socket board, so companies are able to easily test and program the OSMs. And complementing your system on modules, we have the complete ODM design and manufacturing services. So starting the ideation, the architecture of your carrier board, complete system integration, FCC certification of your product, and the complete lifecycle management. So iWave does not stop at being a system on module manufacturer. We were there with companies all the way from ideation, all the way from to completely supporting you on your product for 10 to 15 years, the whole design cycle and innovation cycle. And that brings me to the end of my presentation. So we definitely look forward and enabling you on the innovation journey with i.MX 93. And from now, I hand it over to Sebastian from Ozone, who's like a software partner for the i.MX 93 and helping iWave as a complete solution. Thank you.
Many thanks, Tafi. I will leave the voice to Sebastian as presenter now from Ozone.
Great, thank you. So Ozone Technologies is a provider of software and services focused on AI at the edge, vision-based AI at the edge. For over 20 years, we've been helping customers bring products to market in the embedded space. And in the last 10 years, we've been especially focused on computer vision and vision-based AI, going back as far as the i.MX 6, where today we have customers with production deployments in the hundreds of thousands of devices deploying vision-based AI on parts such as the i.MX 6 and going all the way up to more current parts, as we'll be talking about today. Oh, there we go. So our main piece of software on the embedded device is our DeepView AI middleware stack. So that's what we'll be focusing on today, and especially the lower level component, which handles interfacing with models. So taking camera data, running models, and doing something with the output. In terms of what the middleware stack comprises of, it sits on top of standard operating system or RTOS in cases where we're running on the microcontroller, and sits below the customer's application. Provides the inference engine. Vision Pack is the set of libraries for providing the vision pipeline interfacing with the camera, and various accelerators such as PXP or other 2D accelerators for helping passing images into the inference engine and neural network accelerators. Model Pack is our collection of optimized models. So you can bring in either open source models or retrain them using models that have been specifically tuned for the types of accelerators on the 8M Plus and i.MX 93. On top of that, algorithms such as object tracking to bring context to objects across over time, and other pieces of software to handle things like streaming video, providing web interface where you can see the results, or local interface and things like that, just to help with development. So on the Vision Pack piece, it provides, again, the accelerated end-to-end pipeline. So when we say the performance benefit here, it's not just the actual model running on the accelerator. Typically across different inference engines, the performance is going to be quite similar. Maybe you can get double the performance by having more optimized ways of mapping your tensors and operators onto the accelerator. But to really maximize the overall performance, you need to be able to minimize time spent adapting camera frames to get them onto the accelerator, and the amount of time you spent on the post-processing. So going from the raw tensor outputs to something your application can work with, bounding boxes and a standard structure with dimensions that you're familiar with, or it's head pose angles or skeletons, things like that. These are all algorithms that can take some time, that are hidden when you're benchmarking just the model, and that's an area where we focus on optimizing. I have an example here just showing a comparison of a standard MobileNet SSD running, in this case it's running on an 8M Plus, and showing the end-to-end time. So this is like from the time you capture a camera frame to having boxes that you can work with. We show how we were able to accelerate that by a little over 2x through the Vision Pack pipeline, and beyond that, by leveraging our optimized model pack model, we're able to get another 2x performance from that for overall roughly 5x performance improvement. So on the model pack, it's a optimized detection model. So similar to SSDs or YOLOs or CenterNet models like this, but where we spent a lot of time optimizing it for the 8M Plus and Ethos NPU accelerators. There's a lot of performance that can be gained by tweaking a lot of little things in the model's architecture. Every NPU kind of has its own quirks, and that's the area we focus on. What it results is a model that's roughly 15% more accurate than state-of-the-art models like YOLO V5, and can be three times faster. So in this case, when we say YOLO V5, it'd be the type that'd be running at these types of speeds on the embedded device would be a nano, and still there's a huge gain in performance that can be had. It goes beyond just detection. There's a little error in the slide, but it can also handle segmentation. The segmentation model is very optimized. It adds a roughly 20% overhead over the detection model. It can work with multiple heads, so you can separate your classes to which you want segmented, which you want detected. You can get a bounding box around objects as well as segmentation masks. So it really lets you, deal with flexibility for different types of use cases. In terms of performance, it's roughly 15 times faster than Deep Lab, which is a comparable segmentation model for embedded devices. And then in terms of object tracking, this ties into the object detection output decoding and is able to add tracking. So it gives context to bounding boxes across frames. So where, normally if your application is dealing with bounding boxes from one frame to the other, you don't really know that object's the same. You can infer it based on, it's in the same location, but as objects move and objects cross, it can get, more complicated to track. So we've had that algorithm bundled in and able to provide this at a very minimal performance overhead versus standard bounding box. And this allows applications such as this to be developed. So it's a bit going on in the slide, but this is all one view of an application. So it runs as a web app collecting metadata from cameras with i.MX 8 or 93 based devices. They send object locations and tracks. So it detects people, tracks them. So we know, person A is different from person B. And then based on a homography, translates where those boxes appear to the monocular camera to where they're positioned on a map, like an overview of the office. So you can see in the bottom left, they're like historical trails of where people walked around. In the top right, it's a heat map of where people, are spending time. And then in the bottom right is just a live view of where people are positioned. So this is just one example of, what can be done when you, take detection, add tracking, and some additional processing that's offered as part of the middleware stack for different types of solutions. So now we'll look at a little example from the our application zoo. So the AI application zoo, think like a model zoo, but packaged with an application to actually show it running. So these applications are visual, not full kind of solutions, but they let you see what types of things that can be implemented. Especially interesting one on the right side there is robot puppeteering, where we're using head pose to control a robot in real time just over RS-45 link. If you go to the apps.deepuml.com, there's plenty more examples. They're all downloadable today, which you can run on a i.MX 8M Plus, and these applications will all also be available on the i.MX 93 in the future. So now we're going to focus on showing how the underlying stack to develop these demos is highly portable between i.MX 8M Plus and i.MX 93. So as these i.MX 93 devices come online, you're able to kind of run it on one platform or the other. As you saw, there's a very similar, the same form factor between the 8M Plus and 93 from iWave. So on the left side is showing 8M Plus G40 kit. So it comes in a package with camera, the enclosure, and everything. Form factor is the same as the 93 on the right side. Does not yet have the nice enclosure and everything, but that's something that will be coming. So for this one, we're going to show body pose, and I'm going to play a quick YouTube video that just kind of shows the setup, and then we'll show what we mean by the portability. Okay, probably don't have much of a career in acting, but one clarification from the video, when we mentioned the 720p on the 935 is really with regards to drawing the graphics. The actual vision pipeline is able to be quite optimized. The PXP provides great pixel acceleration for getting things off your camera into the MPU. The MPU on the 935 is very comparable to 8M Plus. It's lower power, so uses less power, a little less powerful. But for example, a detection model running at 60 frames per second on the 8M Plus, there's a good chance you could probably hit that same metric on the 93, because the actual timing difference, whether your model is taking 10 or 14 milliseconds, is you're already pretty close to that 16 millisecond timing for 60 FPS. And as resolution goes up, it affects obviously the throughput, but for different applications. We on the 8M Plus are running models at up to native 4K. So that's a model input taking full 4K video, not downscaling it, and doing object detection on there. So that's important when you're trying to detect very, very small objects. So something like that on the 93, not actually sure if the interface supports it there, but would be, maybe it's 50% slower, but at that time you're really focused on being able to do these types of detections in real time, but not at high speed. So think 1-2 frames per second, not 60 frames per second, but dealing with pretty massive video size. In terms of implementation, so we'll walk through a very basic example showing how you could implement the skeleton pose. Examples in Python, the same applies to C. The libraries are all based on a C API. There's a Python wrapper around it that provides some convenience. You can use numpy arrays directly, things like that. But otherwise, under the hood, it maps to the C API. We've benchmarked with full video camera graphics. The overhead from using Python versus C is in sort of a 5% overhead or less. And the reason for that is basically all the heavy lifting happens in C. If you're using other programming language, the same kind of applies bindings into C, or generally the lingua franca. So then go to medium blocking. All right. So for this example, this is it in 13 lines of code. We show importing the required libraries, creating a context for one of the included models, and then what the main loop looks like. So the couple of imports for the components in Python. The next part is creating the context. Now the software package, Vision Pack, bundles a collection of human-centric models that are ready to go. In one line, you just say, give me that, and it goes. So human pose, face detection, people detection, skeleton pose, those are all packaged and ready to go on both the i.MX 8 and 93 platforms. You can bring in custom models as well. Basically, you would still create a context, but instead of requesting a model type, you would call, load model and give it the model that you're looking to load. The actual model conversion for the devices can all be done on the desktop using the EIQ portal. Camera stream is created, so this kind of hides the complexity of using video for Linux under the hood into this this simple object, but you can also replace this and use GStreamer, video for Linux, lib camera, whatever you will, as long as you can get a frame, ideally a DMA buffer back frame, which anything from video for Linux or lib camera or GStreamer will give you. Then it enables the optimized pipeline to function. So the main loop is basically capture a frame from the camera, load image. So what load image does, this is what is normally the pretty tricky part to get right in terms of adapting the frame to the target. So it will take the DMA buffer of the underlying camera frame and automatically leverage the PXP to adapt that frame to what the MPU needs. So regardless of if you're on the 8M Plus or the i.MX 93, it'll use the correct hardware accelerators. It'll do the adaptation based on your model. So it knows how to probe the model for what the input size, shape, and channel count, and then is able to do that that conversion. Finally, we run the model. Basically, just now it's got its inputs loaded. It evaluates the model, and the outputs are available. And then the key points. This function changes depending on the model type you have. So a detection model would be context.boxes, and it would return from Python just an array of bounding boxes that have your box coordinates. So like where the actual rectangle of the bounding box, labeled, confidence. If you're doing pose in terms of like head pose, it returns the Euler angles, so yaw, pitch, and roll. In this case, it's human pose, so it returns key points, which is just basically the skeleton, the joints in the body. It's not the API is not human centric, so if the model was trained to detect dog poses or the position of a backhoe or crane or something like that, the API would be the same, the model would be different. And then for brevity, we just say print, that would print on the console just the location of those points. But the applications we showed before, they just replace that print with basically the GUI outside the scope of this, but the overlays you could draw with OpenCV, with something like Cairo. On the 8M Plus, we're using OpenGL to draw the primitives on the screen. On the i.MX 93, we use the actual primitives are just drawn with Wayland calls and then blended together using the PXP compositor. But in terms of graphics, it's kind of open, whatever you want to use. Another option is to stream the video along with the metadata to something like a browser interface where you can quickly see how your model is performing. These are typically just done in development time. For an actual product, you're really just concerned with the metadata. Well, edge processing is about sending metadata somewhere, not streaming the video. And again, in terms of portability, the difference for this sample between the i.MX 8M Plus and the i.MX 93, it's basically that one line of code. On the 8M Plus, the camera device is on Dev Video 3, and on the 93, it's on Dev Video 0. So that got changed between the two, but otherwise the same Python code, or if it was using the C API directly under the hood, would be able to move across between the two, where all you need to focus on is your application and with what amount of horsepower do you need and whether or not you need more optimized graphics. To take a look at this stuff, it's tied into EIQ Portal today as well as standalone. So if you're using EIQ Portal, you can test training model pack for detection right in the GUI. For segmentation, you need to use an alternate workflow just to support segmentation data sets. And for that, if you go to our website, you're able to find out more information. Vision Pack, again, you can start a trial right from the EIQ deployment screen, or again from the website. So to see more on that, you can go to edgefirst.ai, or the site before, the apps.dpml.com. Basically different domains, they go to the same place, and you can see the various applications that are available. That's it for my part of the presentation. Thank you very much.
Many thanks, Sebastian. You show more than what we're talking about. So you show the G40K kit we made for the people who want to implement intelligent artificial technology on the 8M Plus with a full ecosystem, software package, cameras, etc. It's something that we have. Many thanks for that, Sebastian.
Thank you very much.
Do you see my screen?
Looks like I still have my screen up. I'm not sure if I'm doing something wrong, or let me see. Yep, it's back to your screen. Okay, I'll leave it to you now. Thank you.
Thank you very much. So by the way, we will see, we will get the G40K evaluation kit on the 8M Plus at Embedded World. Okay, so just a few things before the conclusion. So as we said, you have access to promotions of the iWave evaluation kit that is not evaluation kit board, let's say, which is an ITX SBC based on i.MX 93. You can see in the middle here the SoM itself. This board is quite interesting because you have many communication peripheral around, like here you have the Wi-Fi and the Bluetooth modules. On the carrier board, you have the GNSS. On the back side, you have the M.2 connectors where you can connect the LTE modems. The LTE modems can have the SIM card on it, or you have on the back side the capability to connect the SIM, an external SIM, if needed. We are providing a standard display around that, so we have different size that is available, but for sure we have a lot of different, in future we have more than 700 displays that could be, let's say, studied and connected to the board. It's something that we are doing. We have also cameras. We have many cameras that could be offered on top of the standard ones. You have USB connectors, HDMI, USB Ethernet, power jack, CAN bus here, and also the capabilities to connect, to build your own I/O board and connect the board, your board here. So the offer is limited to the two coming months. For the first 100 keys kits that are ordered by customers, with a limitation of two kits per organizations. This is a part number, so I let you to take a pictures for sure. So this is valid through the Future Electronic Organization, and you can contact the local offices for that. At a price of $360 US. The standard lead time for this hardware is into the range of 12 to 14 weeks. The kit contains the board itself, but also the heatsink and the power jack. Okay. To conclude, as you have seen, i.MX 93, which is a dual Cortex A55 with Cortex M33. It's an up-to-date silicon that will give you a good and one of the best price compromise between the performances, also the power consumptions, but also you have seen there's many features related to the security. So if you really want to have your secure application, it's quite interesting solutions. And by the way, we are also inside the silicon the capability to provide you. We have dedicated hardware for intelligent artificial and machine learning stuff to implement fast and performance model into your applications. For sure, when I say small footprints, because you can get very small packaging into 9 by 9 millimeters, and it's also a full product family. Now, to get a short time to market, i.MX is providing many different type of SoM on almost all NXP processors today. But we are pushing and introducing the new OSM standard that is well accepted by the market, and we have more and more requests concerning that form factors. It offers flexibility and I/O integrations and also robustness solutions. And the fact also the SoM has a Wi-Fi and Bluetooth connections. You have less software things to do and port and implement the driver. You have access to a full ecosystem with cameras on demand, TFTs, heatsink, heat spreaders, and you have also, as you have seen previously, the single board computing, very compact ones, interesting one with many RF for the communications if you want to build a gateway, very interesting ecosystem. Coupled to the Ozone software package toolchain, so you have many different type of softwares. The softwares will assist and help the R&D teams to develop, implement, and extract the right information properly, develop an optimum intelligent artificial models, and send the proper data to the model to get a good and fast performance solutions. It's also nice to change that simplifies implementation into your application and into your silicon, the implementation of the intelligent artificial technology. So it exists also many models already optimized on the NXP silicon at Ozone, but it's possible also to develop custom models. Not necessary for sure videos, and could be predictive maintenance or whatever you want, but they have a lot of expertise into that domain. All of us will be present to the Embedded World, so you're invited to visit us at Embedded World from 14 to 16 of March. Future booths will be in hall 4A, stand 312. You will see all what you have seen there, plus many other things like face blurring, body posture, etc. If you have any questions or requests, you can contact the i.MX expert in future electronics to this email address. And you have seen previously the email address of Ozone and also of i.MX. You will receive in a couple of days an email to where you will be able to download this video, and you will be able to recover the email address of the people. But do not hesitate to send us email and share what you would like to do. And if you have some issue, we will be pleasure to resolve them. So Q&A right now. So we have seen several Q&A. Most of them have been replied to them, but still some of them. Maybe you can switch on your videos. Tofi, Shrir, and Sebastian. You can switch on your videos. Thank you very much. Thank you, first of all, for all of us for the presentations. What are the questions? So it's related to, so they have been shared. I think all the questions, some of them have been shared. Normally everybody should show them, but we still have some. What about the roadmap and BSP for the OSM? So it's Tofi.
Yes, so we use, we have a yearly roadmap of 2 releases with kernel and Yocto upgrades, where we update the source code in the GWS and AWS code commit and deliver it through the FTP links. So we have a regular roadmap of twice a year for the SoM system on modules.
So customer, I want to precise that customer has to contact us to request the access. So you have individual access and private access to the FTP.
Exactly, yes. Customer has to request the latest access.
Yes. Many thanks, Tofi. What kind of support could you give on the evaluation kit? Okay, so there's many different type of support. You take the leads, Tofi? Or?
Yeah, so along with the evaluation kit, we give the complete support as like the PSP customization. And once customers start developing the career code around the system on module, we do the hardware review, the schematics, and the layout review, so that customers able to go more confidently to production. So that is the type of support we give together with the EVKs.
Many thanks. We also have in Future Electronic specialist FAEs who can support customers. So we are working together between let's say iWave and Future and you to review that. But we are from time to time also developing adaptation board between the board itself and cameras or whatever you want. So we have that capability. So it's really a full design support and software support on some case. By the way, okay, this answer had been, let's say this question had been answered. Can we run 3D graphical on the processors? Who want to answer? Shri or myself or Shri, you can answer?
Sure, yeah, let me, so what's the question? Sorry.
Can we run 3D graphic on the processor?
So as I mentioned, the chip does not have a dedicated 3D GPU, but we have shown that like the A55 can be used to run the graphical operations if necessary. So please contact me or let me know. I can provide some details on some results there. But we have shown the PXP along with the A55 can be used to provide run the 3D. Obviously, you're going to use the A55 resources, but still if you have some graphical heavy application, you can run it on A55.
By the way, there's yeah, go ahead.
It's, a lot of graphics, you can have pre-rendered, 3D, and it comes down to really 2D graphics. So, for these different AI demos, the actual graphics themselves are either pre-rendered, like PNGs or SVGs, or fairly simple, lines and shapes on top of things. The PXP can do compositing of that at high resolution, very, very low time, and low impact on the CPU. So it's maybe a little bit more involved than using a lot of these prepackaged stacks that are based on OpenGL, but you can definitely do quite a bit with a PXP.
By the way, yes, it's a 2D engine that is inside, and the 2D engine is also supported by let's say graphical software libraries if you want to develop GUIs or whatever you want, like Qt if needed. It's already available and you can run it on it. What is the maximum eMMC size supported?
Okay, that as a standard we have 16 GB, but it can go all the way till 256 GB.
Right. I confirm. We have chips up from 4 giga to 250 gigabyte. Yeah. We are using standard packaging, which is 153 ball packaging, which is a totally standard solutions. Okay, what is the power consumptions in no power mode? You give some idea about the solutions?
I can't comment on power, but in terms of performance of the MPU, what we're seeing right now is probably typically about 50%, overhead. So it takes 50% longer to run a model compared to the 8M Plus. To put that in context, the 8M Plus has been around for a few years, and these models are now pretty highly optimized for the part. So the fact that we're already seeing that close from a lower power part is pretty promising.
So i.MX 93 has a better position for the power consumption. Yeah. Okay. By the way, it's already, if I remember well, 18% less in terms of power consumption compared to the Cortex A53. Okay, can we support multi-display applications? For example, DSI, LVDS, or in the same time? Will it be possible?
So the LVDS, BPDSI can be connected to a screen, but you're going to see the same image on both the display. So you cannot have two independent display basically, because we have a single engine processing for the display capability. So you can connect it to LVDS and BPDSI, but you're going to see the same image or same content on both.
The silicon is already optimized to give a good performances and good price, so there is less feature than the 8M Plus or the i.MX Quad Max for sure. VPU, GPU supported. So GPU, we said that it is a PXP GPUs. So for the VPU, no, there is no hardware VPUs into the i.MX 93s. For sure, it is possible to do a software VPUs. So you can imagine to do some video encoding or decoding functions by using the second core if it is there. That's almost all. Okay, so I would say many thanks to everybody. Many thanks, Shreer, for the presentations. Tafi also, many thanks. Sebastian also. Don't forget to come to Embedded World. You will see many hardwares, many demo running on intelligent artificial, not only and based on the i.MX RT, so very small Cortex processors, i.MX 8M Plus, i.MX 93s. If you want a private meeting, or because you want to share a project or some complex system, or you don't know how to proceed, do not hesitate to request private meetings altogether. We will be very enjoyed to try to understand your problematic and try to provide you solutions. Many thanks for everybody. Take care to you. Thank you.
Thank you.
Thank you. Thank you, everyone. Bye-bye.
Thank you.
Bye-bye.